Okay, guys. So in previous one, I already worked on these problems with the first solution, but I want to try to do with another solution. It's gonna use breadth first. So we use depth first, we're gonna use stack. But in this case, we want to try another data structure. We want to use a queue, which gonna be breadth first. This is, I think, either both of them, the time and space will be the same, but just want to practice with multiple data structure using, we already using stack with the first, right? So in that case, then in this video, we're going to use queue. We're gonna use bed first. So let's see what I can do or not. So, okay, so we know we're gonna have a queue. So I think at first we're gonna have like, in that case, right? Let's think about, okay, so check if no root. So in that case, we're just gonna return 0. At first, I think we want to the define the variable to store. We want to store maximum, right? So that's maximum should be uh, set to 0. Okay. And then we check if there are no roots, we want to gonna return a maximum variable. Maximum. Okay. And then we're gonna have to define queue to store root, right? And then we iterate. We're gonna check while we have queue is not empty. We're gonna do some logic inside here. And the end, we're gonna return maximum. Maximum. I think we can say depth, right? So we define depth. Let's say here, we're gonna say define depth using let because we're gonna have to reassign later. And we're gonna check if no root, we just gonna return depth, which it should be empty, which should be 0 at the first, and then we not need to go through later on. So just returns here, we return depth. Okay, do I spell correct? Okay, yep. And then we're gonna have to store Q. Q is gonna be at the root or the root node or the node, right? And then we're gonna have to say whilst Q is not empty, NTTHQ greater than 0, we're gonna have to work on logic here. So we know that on the breadth first, we're gonna have to iterate on each level. So let's say we have root at 3, right? Each level, we're gonna have to define. So I'm gonna have to define a level. Level, we're gonna say q.length because our q gonna change each iteration. And then we going to iterate through the level. And so using for, in this case, we're going to say let I 0, I less than level. So each level, we're going to change on each queue, and then I increment by 1. And what we're going to do here, we're going to iterate. Oh, 1 second, we want to get a node using chip, right? The queue, we're going to get the first in, first out. So we're going to say cur node. We're gonna be q.chip. So we chip on each one. And then we're gonna iterate to each travel to left and right. So we're gonna go to left first. So we say cur node dot left. And then we're gonna push the value to the queue. Okay, we're gonna push cur node to the queue. So other way too, we're gonna say I'm not sure if it's work of a second curl node, so that's gonna be right. If I not correct, I gonna think another way. And each iteration, we want to increment dip here. So then it similarly hit the first, but in that case, we don't need to compare until we don't have anything left in the queue. So that will increment. Which I'm not sure if that work. Let me try to think. Um, Let me see if that work. Is it? No, it should do, right? But the first, hmm, should we, can we do, can we do it? Can we do it? Let me try to think. Do we can do, I think that should be work. Oops, sorry. What? Oh, where is my screen? Okay. Oh, no. Oh, max, right? Okay. So let's try to see if that work. Let me think. We can try to run, but maybe not work on this case because this means we're gonna iterate all the way. So that's gonna be one. Let's try to run. Okay, that is not work. That's why we increment every level, either left and right. That's why instead of return only one side, we return three. So, or maybe I think we should increment outside. That's not really good. Okay. That should be let's submit. I think I might not understand how it works. So it's work, let's submit. Okay, it's work, so let's analyze so the time and space. And then we can come back to see. Okay, so the time and space also O of n with I did the wrong idea. Okay, let's see here. Okay, what is wrong with my first solution here? We iterate to the queue here, right? So when we iterate, we want to travel uh, it the new node on each queue. Okay, so first each level we add queue, right? So let's go here. So first our queue will be 3, right? So it's queue not empty. So we want to get a queue here. The length is 1. And then we iterate to the level of 1. Then we chip it out. So we chip 3 out here. And, and then we say if we have, so now our queue it should be empty. Okay, so we have 3 here. We don't do anything. But we want to do here, we chip our queue is gonna have check if our queue is the current node is a root, right? So we check if there are a left node, which is so number 9. So we push the queue. So now queue will be 9, right? And then we go to the right and queue. Oh, sorry. So we have 9 here, and then we check, is this left still? No, no. And then we go to right. We go back to right, and then we check current node on the right, which is we're gonna have to, we push right to Q, which is gonna be 20. So we have 9, and we're at 20. And the Q is here, chip it out. So Q is now 9 and 20. So come to the second level. So now the level will be through. So we iterate. Oh, the first thing we iterate only one. Okay, yes. Okay, is correct. But then at first, when we finish at the first level here, 1, we increment, so our depth will be 1, right? And then we move to the next level, which is Q is greater. So Q is have 9 and 20. So we come here, the Q is 2. So we iterate to 2. So we ship, first we ship it 9 out. We ship 9 out. Now Q, we have 20. Okay. And we say, is it left? Yes, we have left it 15. So we going to wait. So curve node is left with seed check. No, we don't have here. So we go to right, and then we add. Wait 1 second. Let me think about that for a second. That's just a little bit confused. Okay. So first, oh, we have 9. Okay, let's say again. Go back here. We have number 9 and 20 in the queue, which is left and right. And our level is 2. Okay, so we get the new node from, we ship it out. So we say like 20, right? And then we ship first. So we take 9 out. The queue is 20. So we check, is it left? No, we don't have here because 9 doesn't have. And then if it's right, no, we don't have here as well. We not push anything. Yep, we not push anything. So that's it, gonna be okay. And then the next, we already ship it out here. So our queue will be 20. We go to here, length is 1. Oh, so second, sorry, before we come back to here, the queue still increment 2, so it's gonna be incremented to 2. Okay, now we come back to here. We have is it queue? Yeah, we have 20, right, in the line. And then we go down to increment here. So we say, okay, we keep it 20. So now the queue is empty. And then we check if current node is empty, is left yet. We have 15, right? So we put 15. And is it, this is gonna be empty. Is it right? Yes, we put 7. So we increment to 3. With it, the queue is already empty. So we're not gonna do anything. That's why we return 9. Oh, we return 3. So, okay, so let's submit again. Okay, that is so complicated when you walk through the 3 though. But yeah, I think for both solution with easy problem, let me understand a little bit how to work on both. With the first is my easier, but first seem to be complicated for me in this case. So if I gonna solve this problem when on the interview, I think like depth first, right? So because the maximum depth, so when you see depth, I think I'm gonna use depth first because you're gonna go deeper. You not need to deal with say breadth first, right? Breadth first is go by each level. So in this problem, I think I'm gonna come with the depth first might be easy because you just want to go through the way down. Okay, so that's it for today, and thank you for watching. See you next time.